Okay, yeah. So Akhilesh, would you want to give an introduction about Yantra, or do I just go ahead?
You can start, I guess. No issue.
Fine. Okay. So, okay. So we are here today to learn about Internet of Things, IoT, what it is, where is it being currently used, and how you can work on it yourself in terms of getting to learn the nitty-gritty details of, how do you connect things to the cloud, how do you connect things to the internet, how do you program it, how do you control it, all sorts of stuff. Okay, so I'll just start with a brief introduction about myself. I'm Abhinav Udupi, and we are part of the IIT Madras BS program. So I'm a member of the fourth year, so part of the very first batch. And yeah, so that has I have been taking up sessions on related technology, AI, cloud, programming from my class 9 onwards. Now it's an honor for me to take sessions for the IIT Madras crowd. Okay, so yeah, we'll jump right into it. We'll begin with a bit of a history of why we are in the age of Internet of Things currently. Okay, initially, remember when we had, okay, not we, but our parents' generation, where there were single computers, not really connected to internet, no YouTube, no Gmail, no website. It was mainly used for word processing, for Excel kind of spreadsheets, for doing calculations. Those are the simple use cases. So there was no connection between computers. Okay, then came an age where people thought, especially in places like research institutes and universities, education institutes, people wanted to connect the computers together so that teacher can share something with students, student can share among themselves. Okay, so there we got into something called local area network, and slowly that transitioned into what we now know as the internet. Okay, so among the three, four major phases of internet that we know, one of the first one is the internet of content, which basically means all your web pages, websites, people who had content were putting it up on the internet for others to read, like blogs, forums, question and answers, things like Stack Overflow, all that. Okay, then we moved on to a phase called Internet of Services, which basically is applications on the internet. You have your cloud storage. So you basically use internet to do things. Okay, things like storing data or sharing data. Okay, maybe you wanted to do some work for you. Maybe institute or company has their employee portal on the internet. So that was the age of applications on the internet. Okay, and then next came the internet of people, which basically was social media, where people got connected. And every person almost now currently, as far as statistics go, 5 billion out of the 8 billion people are connected to the internet. Okay, and then we moved on to something called Internet of Things, which is basically every device gets connected to internet, not just people, not just computers. Okay, things like things as simple as your printer, your washing machine, your refrigerator, your doorbell. There are security concerns. That's a later phase, but for the time being, Internet of Things is where every electronic device that can be controlled gets connected to the internet for some sort of smart function. Okay. So as of now, we have close to 50 to 60 billion devices connected to the internet. That is what the scale of Internet of Things is. Prior to this, we had only a couple billion websites, web pages as such. So uh, those are only the amount of computers that are connected. So the rest of the 45, 49 billion items are things that are not computers or other devices which come under the realm of Internet of Things. Okay, so if any of you have doubt in any part I am asking, you can just raise your hand or put up a message in the chat. We can clarify it as we go. Okay, and yeah, so now we'll move on to a few examples of where IoT is being used and can be used. Okay, so before we get into the core of IoT, the internet connection part, we have to look at something called physical computing. Okay, would anyone is anyone having a background in IoT, physical computing? Just raise your hands. Okay, not many. Fine. So I'll go through one simple example. The simplest examples are the appliances we have at our home. You know, you have your washing machine, you have your microwave, you have your refrigerator, air conditioner. All these devices have some sort of mechanism to take input from the real world. For an air conditioner, it can be temperature of your bedroom. It's going to sense that, and then only it is going to switch on or switch off the compressor to cool the room. It's not going to indefinitely keep cooling your room. Okay, so that is one example of what we call as physical computing, where you do computations based on the physical entities like temperature, humidity, distance, etc. Okay, so these are just some examples. Your microwave is also similar, depending on what buttons you press, what mode you want it, how much time you want to set it. Those kind of processes happen internally to keep the microwave production on for so much time. So these are basically a set of components called sensors, controllers, and actuators. So we will come to that a little later. But so anyone would like to give us more examples in the chat box or maybe unmute yourself. So we have a air conditioner, thermostat, uh, washing machine, oven. What else comes to your mind when we think of physical computing, where you do some sort of your digital kind of programming, kind of programmatic things on your physical world? Okay, embedded systems in general. Yeah, so embedded systems is physical computing. NAS, you mean network attached storage? So I am not sure if it will come under physical computing as such, because that is more of, it is a part of computer. It is for storage. Okay, it is basically another computer which has a bunch of hard disks. But uh, uh, yeah, anyone else? Yeah, so calculator also, you can say it is physical computing, because see, physical computing encompasses anything that has, physical components interacting with your electronic and digital circuitry. That can be code, and that can be simple resistor capacitor stuff. Okay, so calculator, of course, you have buttons. There is a microcontroller which reads your button input and does the calculation as per what you do. Clock, again, depends on what clock. Analog clock, no, because analog clock is just a spring-based device. But digital clock, yes, again, there is a processor on board, there is a display on board. Chimney, again, yeah, digital chimneys, yes. So wherever there is digital involved, when it comes to smart fan, chimneys, anything that there is digital part involved, it's of course going to come under physical computing, because it is again working on our physical life and it has a computer based background. Yeah, dishwasher, okay. Hardware that can compute in offline. What does that mean? Could you please elaborate? Coffee machine, yes. Okay. Yeah, so I think we can move ahead. Okay, so next part in not relying on cloud computing. Yeah, so in a way, yes, you're right. Hardware that it is not necessarily not relying on cloud computing, but it is more so as to anything that works with the physical realm, physical entity. Okay, it can or cannot use cloud. So nowadays, there it has become an increasing trend where every random thing gets connected to internet. Okay, it is not like my washing machine wants to watch Netflix. Okay, so it is not exactly necessary. But yeah, correct. Having an option to work offline. Okay, so the next constituent in IoT is a part called cloud, which I think at this point most of us are already aware. Cloud is basically just someone else's computer. Okay, so you are all sitting on computers, either a mobile or a laptop, and someone else's computer is called cloud for us. Okay, if it is YouTube's computer, we call it uh, we it is the web page youtube.com that we use to stream videos and other content. Similarly, there are cloud services for so many requirements. Okay, the simplest one is Google Drive kind of thing, what we call as cloud storage. We use someone else's computer to store our data. Okay, and then another increasingly popular use case that we have now is language models hosted on someone else's computer, things like ChatGPT. Okay, there are tools that you can host on your own computer, so that does not come under cloud as such. But cloud services are basically where you don't have to handle the computers, the power, the security, all that kind of things. You just use it through a web page, chatgpt.com, okay, drive.google.com, things like that. Okay, and specifically when it comes to IoT, there are instances of dashboards that you do where you collect sensor data. So I just yeah, Amazon AWS is a Amazon Web Services. It's a cloud platform. Okay, where you have so many things. You have cloud storage on Amazon called S3. You have virtual machines on Amazon, basically Linux computers on Amazon server called EC2. And there are various other services that you can use from on the cloud. So I can just, yeah, so this is one such cloud application that we know. It is called ThinkSpeak. And again, it's from the same providers as MATLAB, quite popular analysis tool. Okay, so this is one of my old previous projects that I was doing, where we have pond humidity, temperature, all this data being logged for further analysis. So this is quite old, around 6 years old. But otherwise, there are so there are many such tools that so another popular example can be Arduino's cloud. How many of you have worked on Arduino or know about Arduino? Okay, okay. Yeah, I see quite some people. That's nice. So Arduino has recently come out with its own cloud service where your Wi-Fi and Bluetooth connected boards can directly upload data to a platform, to this platform, and you can have real-time analytics from basically anywhere in the world. Okay, so this is the cloud side of when we specifically talk of IoT. And there are multiple other platforms like Car IoT and where is my presentation? Yeah. Okay. So Blink IoT, yeah. So that is we will come to that shortly. Okay. Another popular example when specifically coming to IoT is you must have heard of this Philips Hue lighting solutions by the company Philips. So these are basically color changing lights which are connected to your Wi-Fi. You are able to control it through your mobile application. Similarly, there are things called smart plugs, which basically sit between your wall socket and your plug, which you connect to maybe fridge or AC or whatever other appliance you have, and you are able to use that smart plug to connect to your through a mobile application. So that is a kind of a retrofit of IoT to our existing homes. Nowadays, you have so many other devices that are directly inbuilt into the breaker boxes or the switches, which directly connect to your IoT network, either Wi-Fi or others that we are going to look at shortly. Okay, then of course we have smart doorbells. Okay, and then I don't know if you have noticed, but many cities the government has placed these air quality monitors. So these are basically again a set of sensors in one place and a display in another place, which continuously monitor and real time display the uh, air quality statistics, and also it gets logged to a platform similar to how I showed Arduino Cloud and ThinkSpeak. Similar platforms, government specific, there are there which log it so that citizens can see it at a later point. Okay, so yeah, so these were some of the use, where we get to see IoT and related technology in the current world. So anyone would like to add on anything, any example, or have any doubts? Okay, I think it will be better if it is slightly interactive. Maybe one or two of you can unmute or put it up in the text chat. So there are multiple examples. You just have to, go through your day-to-day routine, uh, how you live your life. You are going to be interacting with so many such IoT and related technology, cloud, IoT, physical computing. Another simple example can be, I don't know if you have gone to certain malls where doors are automatic. You have automatic taps in the washrooms. So when you put your hand, automatically water comes. Okay, and during the Corona pandemic time, we have seen automated sanitizer dispensers, escalator, elevator, correct. Bluetooth speakers. Bluetooth speakers as such are not IoT, but if you have it connected, so things like you have your Amazon Echo or Google Home, the smart speakers, those can be part of uh, uh, IoT. Okay, where it's connected to internet and they have some smart function. IIT Madras Restaurant Gate. I think it would be nice if you could elaborate. We are online students. We have not been to it much. Airport displays, Alexa. Yeah. Sunny, would you like to elaborate? Is it some kind of automated gate, or is it attendance automatic?
Actually, it's like automatic gate. So when you come near to the gate, it will automatically open.
Oh, acha, okay. Okay, okay. So smart fridge. Yeah, so smart fridge is another, I don't know how useful can that be, but there have been instances of the fridge trying to tell you what is the stock of certain items in your home. Cucumber is running low, tomato is running low. Do you want me to place an order? So sometime back uh, there was this thing called Amazon. Yeah, so these small IoT buttons, very low power, battery powered, which are basically single item to-do list kind of a thing. So when something of that particular button related item gets over, you just press that button, it automatically places an order on Amazon. So that was the use case. Did not get much attention. It was popular for a while, but of course, it's very wasteful. You would not want to have a button each for every item in your grocery list. But for the common ones like detergent, or maybe rice, dal, and some common vegetables, think it could be useful. Placing order on Big Basket, placing order on Amazon. So this is also another example of IoT. Samsung phones have feature called modes and routines. I'm not very sure about that. Okay, I don't know much of the feature. If you would like to describe it, maybe I can help. Vande Bharat train gate, yes, that is also physical computing. And RC cars, yeah. Okay, I think that's enough for now. We will move ahead. Yeah, sprinkler system is also good. We are coming to that. Oh, okay. Yeah, so okay, well, we will come to that most probably in tomorrow's session. But similar to Samsung, there is Apple HomeKit, there is Google Home. I think Google Home. So these are basically ecosystem of smart products that a particular company has built and is closed source. Okay, so it is as you just said, you can automate things that are only in the Samsung ecosystem. The Apple HomeKit users will only be able to interact with Apple HomeKit certified now, the smart ecosystem, as I say. But yeah, we are close to getting to a point where we have a universal system where any device can talk to any other device. That way, so there is one very important and very useful tool called Home Assistant that we'll be covering tomorrow. Okay, tomorrow as in the next session, and that is going to be. We'll see how useful it is to actually have your own control instead of giving control to Apple, Google, Samsung, LG, things like that. Okay, yeah, once you get into the ecosystem we cannot, so that is how they build it. So they want you to get stuck to their ecosystem so that you keep buying from them. So that's a business tactic, and I think we can just keep it aside for now. But yeah, so we will move ahead to some use cases in IoT. So till now what we saw were few examples from our real life. Okay, and now is it is kind of where IoT can be enabled to improve that particular sector. So that is our idea now. Okay, our most important, again, India is a agrarian country. Most important for us would be agriculture, and agriculture both in terms of plants and also fish. That what comes under aquaculture. Okay, so would anyone like to share what comes to your mind when saying smart agriculture? What can be made smart in agriculture? It would be good if one or two of you can unmute yourself. Hello. Okay, using drones. So I am asking more about the on-ground use cases. So yeah, disease detection is one. Okay, so disease detection through okay humidity monitoring, soil testing, automated irrigation. Yes,
Yeah, can you please turn on your mic?
Yeah,
yeah,
yeah.
yeah,
So there are multiple systems like automatic sprinkler, like irrigation, and there is
yeah.
like
Correct,
soil testing and autonomous weeding, and these are all could be a part of the IoT system.
correct. Yeah. Okay. So yeah, so all of you are correct. So we have basically the point of IoT is to be able to have proactive monitoring for the farms and related spaces, not just the farm. So we are also talking about tracing. There have been quickly I'll go to the yeah. So there is a company called Urban Kisan, if you have heard. So they do something called hydroponics, which is basically a modern form of agriculture, soilless agriculture. So here they have a system where you are able to exactly say when the packet of grocery that you just picked up, cabbage, palak, whatever. When you pick it up, you have a QR code which tracks its entire journey from the farm, from when it was harvested till when it has come to your kitchen. That way, you are able to know its quality, you are able to know its freshness. Okay, and this is the customer side thing. So for them also, it's going to be useful in, as y'all have told, monitoring humidity, temperature. Okay, and when you get into fish and water based water-based culture, you need to take care of so many things. Okay, especially when there is fish, you need to take care of ammonia, nitrate, nitrite, pH. So all those things, monitoring those things and trying to put it up in a centralized view where in places like Arduino Cloud or in places like ThinkSpeak, or there are again other IoT solutions on Amazon, Google, AWS and Azure, Microsoft. So there are IoT tools on those cloud services that you can use to do analytics and machine learning, okay, and do predictive maintenance. So I'll just take a slight deviation. I will talk about one of my solution from some time back. Okay, so just to set the stage, I am one of the top 100 young innovators designated by Niti Aayog, central government, in 2019. So there was this Atal Innovation Marathon that was there, and so one of the solution I put forward was related to aquaponics. That is basically fish culture. Okay, so I am from Udupi, as you may have guessed from my name. So Udupi is that coastal Karnataka area, coastal South Karnataka. We have a lot of fisheries and aquaculture uh, places here, farmers. And my idea was to again proactively monitor and predict problems for the farmer before actually anything happens to the fishes, the fishes and other aquatic life. Okay, so typically in aquaculture, what happens is you have ponds which are generally murky, muddy water. You will not be able to see much inside, and you have fishes. It is fine for the fishes as such, but if it causes any, any disease or any feeding problem or things like that, the farmers are not able to know unless they go and pick out the fish. Okay, that is most probably in the harvest time. So in the harvest time, when they come to know that the fish is not well or it has not grown because of low feeding, they are not able to do anything at that time because generally harvest times are pretty tight. Okay, so my solution was with a bunch of sensors and camera and stuff. It was to do analytics real time. You are able to monitor your pond, and also you are able to get predictive analysis. There's a storm coming, maybe you want to cover your pond. So there have been instances, farmers have spoken to me, they have told overnight they have had multiple lakhs of, yeah, I'll come to that, Kunal. So there are farmers who have told there were multiple lakhs worth of damage done just because one night storm happened. Storm in the sense flooding of the nearby ocean water and drainage water, things like that. So if you are able to predict weather patterns, you are able to real time monitor the quality of water, you are able to better take care of your farm. So that was the solution. So this ThinkSpeak thing that you saw was a prototype for that. Temperature and humidity, these are the low cost sensors that I could find. Okay, then there were other sensors, pH and all that. So I have a bunch of sensors actually on my table. I'm going to be showing it towards the end of the session. Okay, yeah. How is it possible in rural areas? So are you talking about the connection, the funding, and things like that? I assume yes. So our idea was to again keep the cost as low as possible, have it subsidized by various fisheries related organization, government level, and also keep it solar powered and minimum subscription cost for the application and analytics. So that was the plan. Okay, and then certain things happened in my life and academics and stuff, so I was not able to pursue it as much. Okay, so we got into prototypes phase and we had a number of boot camps. We got into internship at IBM and stuff, but later I had to focus on other things, so I was not able to pursue that. But the original plan was uh, you have a minimum subscription cost, and then it is solar powered and it is very low maintenance, and the farmers are only able to reap the benefits. Okay, and as far as product market fit goes, many farmers have actually spoken. I spoke to many farmers and farmer union kind of thing, and they have agreed that such solution was required, and they are waiting and willing to procure such solutions. Okay, so it is not. I wouldn't say it wouldn't be possible, but there was work to be done. Of course, it is not as easy as saying it is there on Amazon, go buy and put it in your pond. Okay. So yeah. Okay, so yeah, that was about smart agriculture. Okay. Also, on the just as I saw that infographic, not just our growing the plants, but also monitoring existing forest cover in terms of forest fire. If you have temperature, infrared sensors, fire sensors in random places in your reserve forest kind of thing, you are able to track if untold forest fire occurs, or maybe even if it is man-made, someone throws a cigarette butt and thinks it started. Before it becomes huge, you are able to notify the authorities saying there might be fire in this particular area. So you have location sensors, you have fire sensors, you have communication to mobile application in your local police station. So that is the entire uh, that is the entire solution when it comes to IoT. So can you explain aquaponic farming? So it is slightly beyond the scope. Okay, not slightly. It is beyond the scope of this session. So this is more about IoT. Aquaponic is basically using fish waste to grow plants, to using plants to purify water for fish. Okay, that is in a very simply put. But again, it's going to be outside the scope, and I will continue. Okay, another use case is healthcare, patient monitoring, connecting doctors with patients. Super specialized doctors are not everywhere in every hospital. When some patient in some rural place needs some very specialized doctor, very specialized research professional, so tools like these kind of IoT based solutions are able to directly connect consumers with producers of resources, doctors to patient in this case. Okay, and I think Apple users may already know Apple, the smart watches, they already have features where they directly inform healthcare professional in case you have a certain health problem and you actually agree to it. Okay, it sees your heart rate, it sees your oxygen, and you're able to call emergency services as soon as something happens to you. Okay, so smart watches, that is the sensor part of our smart healthcare. Okay, anyone would like to add on anything? Yeah, Google Fit is also a similar use case. So basically, smart watches and smart bands which are collecting health data. Usually, it is only pulse and oxygen saturation, but sometimes it is also your movement data, your sleep data, sleep patterns, things like that. And that data, in the most common way, you just get to analyze it to yourself. You are able to see I slept for 6 hours yesterday, and three of the hours were deep sleep. Okay, so you are able to see there are all those different stages of sleep. So whether I'm actually a deep sleeper, those kind of analytics you can do with simple smart bands and Google Fit and Apple Watch and those kind of things. Okay, another use case is smart waste management. Okay, it is again quite simple. You want to monitor, degradable waste and plastic waste. You want to track all their life cycle such that as a consumer and as stakeholders in the government or organization, they are able to see how waste is actually being handled, either to take administrative action or to take preventive, curative action. Okay, and things as simple as seeing whether the garbage can is full. Okay, whether to take the to empty the garbage can, because having the truck come to the garbage can every day can be waste of time, can be waste of fuel, greenhouse emission, all that. So if you are smartly able to tell whether to go to that locality to collect the waste, it is a win in terms of economy, amount of fuel burnt, and all that. Okay, another very popular and upcoming use case can be smart city, where your vehicles, traffic moderation, and again, of course, air quality, as we spoke, all of them are connected to a central point where I think certain places are already you can, when you go to huge malls and stuff, they tell you how many car parking slots are available, how many bike parking slots are available, and that is in real time. If two cars leave the parking, immediately the count gets updated. So those are based on various sensors and various human input. So a person inside can immediately say one car has left. That is also possible. Or you can have camera based sensor which count number of cars in a certain area. So parking moderation, traffic moderation. I'm not sure if you have heard, but the company has recently tied up with Bangalore traffic police to do the traffic moderation using the Google's AI and all the analytics. So their way is, of course, to go from point A to point B, there are multiple routes, and uh, Google generally shows us the shortest and most economical route, or route without tolls if you ask it to. But with that contract that was signed, I don't know how far it has come, but that was, I think, 2 years or so back. There was a clause where they wanted to moderate traffic based on, Google has data of literally every smartphone. Every smartphone runs Google nowadays. So Google has the location data. So they wanted to track how many people are on each road and tell people to go from different road in case one road gets jammed by traffic. So that is again another use case of IoT, where you don't have another set of complicated sensors and controllers. You use your mobile, which already every person has. You use the GPS in the mobile, and you use Google servers, GPS satellites, and you do the analytics as such. Okay, so yeah, that is one. Okay, so anyone would like to add on anything to smart city waste management? Okay, another popular and well-versed use case I can say is smart home, where from simple things, automatic light when person is entering the room. You can use it to save electricity. Whenever I leave the room, AC automatically turns down, light fan automatically switches off. When my tank gets filled automatically, my water pump gets switched off. These kind of things, simple automations which are going to be improving quality of life, but also save energy, save electricity. So anyone would like to add on to this? Okay, please give me a minute. Yeah. So cloud based light functioning, yeah. So that is another use case. And as we spoke about Alexa and stuff previously, so you are able to voice control your home. Okay, that is also possible. Okay, as I was telling, I was talking about home assistant. So that is one such tool where you are able to, in your own home, within your own control, you are able to automate so many things when it comes to the home and IoT in general, but it is meant for home automation. Okay, you can use it to automate anything. It is just a tool for having dashboards and connecting devices. Okay, so uh, in for people who are not wanting to set up separate servers in their home, it is good enough to use things like Amazon Alexa, Google Home, Apple HomeKit. Okay, but the point is you are tied into their ecosystem, and you have to buy things that are only specifically working with Google Assistant on Alexa. You cannot, if it does not work with a certain protocol, it will not work. You cannot make it work as such. So that way you are locked down by what Google allows you to use, what Apple allows you to use. Okay. So yeah. So, so these are some of the use cases. Would anyone like to add on to any use cases I have missed? Okay, of course I missed a lot. Okay, I am just another student, and I'm just taking sessions with knowledge that I have gained over the years. But if any of you have anything to add on, please add it. Share it with others also. Okay, so I think we'll continue. Okay, so yeah, we looked at use cases of IoT. Now we will go towards what actually constitutes IoT. Okay, what are the parts of IoT as such? Okay, as far as our discussion has come, we already know there are sensors, there are controllers, and then there is networks like Wi-Fi, Bluetooth that connect, and then there is cloud and analytics that we do. Okay, so these are generally the main parts when it comes to IoT. Okay, sensors and actuators are two things that actually interact with the physical world. Sensors are like our sense organs. We have ears, eyes, skin, nose. These basically take inputs from the physical world. Your eyes are taking distance data, visual color data, visual, the image data. Your skin can be temperature data, touch data, and your nose has olfactory smell-based data, which is uh, there is no exact analog in the digital realm, but uh, your nose is able to sense certain gases, certain compounds. Okay, like your gas cylinder leakage, we very distinctly recognize that smell. So those kind of which are in the form of various sensors and actuators. Electric data. Okay, that can be temperature data, that can be distance data, things like that. Okay, and actuators are basically the opposite. They are like the muscles of our human body. Okay, and muscle is the only actuator we have in the body. Electrical signal put physical world.
Hello,
Okay, either in form of movement in the,
hello.
yeah,
Abhinav, I think
yeah,
your
Akhilesh.
network's a bit weak, I guess.
Uh,
Your voice is cracking a bit in between.
okay, is it fine now?
Yeah, but
Okay, yeah. So yeah, so actuators, we are coming back. Actuators are basically devices that take electrical signal and put it back into the physical world. It can be in the form of light, can be in the form of movement, okay, and things like that. Okay, what should we do in railway track to innovate? Again, it is out of scope. We can get in touch, Kunal, and we can discuss
we
about
can
it
have a
later.
discussion in the group.
Yeah.
No issues.
Okay, and then comes controllers, which are like the brain. Okay, in the human, how we have the brain and spinal cord, which take in all the sensory data and put it into the muscles when we have to do something. So controller is that job. So there are various types of controller, from very low powered ones to very high powered ones. And the highest in the sense, the most complex controllers are full computers, which you can do so many things on, multitask. It is not a it is not a specific purpose thing. Okay, you can use it to browse, you can use it to program, you can run applications, web servers, you can do simple calculation and all that. Okay, but when it comes to IoT and physical computing, controllers come in a variety of complexity. Okay, again, we'll come to that. I think. Okay. Okay, and then comes the network, that is actually the communication between the different devices. The internet as we know it is based on three primary modes of communication. Okay, the internet as such, not the IoT part. So the internet, when you say you have internet in your home, usually it comes in the form of a Ethernet wire or in the form of fiber. Okay, so fiber and Ethernet are two wired forms of internet transmission, and Wi-Fi is another wireless form for the local area network. Okay, so these are three common ways of networking for the internet. But when it comes to IoT and physical computing, there are various other technologies that have come up. We are going to be discussing more about this in the next session. Okay, and then we come back to analytics and dashboard. So after collecting all the data, after doing all that, we want to see what we have done. We want to see the real time, say for example, temperature, humidity data. Okay, so that is where dashboards and analytics come in. Dashboards are only showing you the data, and analytics are where you perform analytics either in the form of machine learning, or you learn some patterns in the data, you predict something from the data, or it can be as simple as finding out the average, finding out the mean, median, mode. These are also forms of analytics that you do on the data. Okay, so that is the uh, parts of IoT asset. So we'll move on to uh, I have a bunch of things to show you. Okay, I will just switch on the camera. Okay, so these are some yeah. So these are some sensor examples that we have. Okay, so the simple ones begin with, you have a temperature humidity sensor. So this is for the air quality monitoring part. And then you have a waterproof temperature sensor for pond and water tank and aquariums and things like that. Okay, then you have various types of gas sensors. Okay, gas is to sense the environmental, the gas composition. So this particular sensor is for smoke and carbon monoxide. Okay, then you have soil moisture sensor, which is again, most of these sensors are self-explanatory. So you have a turbidity sensor. So this sensor basically finds out, uh, you see the difference between clean water and say muddy water or milk. It is more opaque. So that opacity of liquid, this sensor measures. Okay, then you have uh, obstacle sensor. So this is the infrared obstacle sensor. You have distance sensor. So this uses ultrasonic waves to measure. We have this simple formula: speed equal to distance by time. We know the speed of ultrasonic waves in air. We measure how much time it takes for an echo, and you measure the distance. So this particular thing has about, I think, 30 meters or so range. Then we have a light sensor. So this measures the intensity of light. We have touch sensor. So most of these the sensors are quite self-explanatory. I have so we have pH sensor here. So this measures how acidic or basic the liquid is. So again, this was used for the aquaculture project that I was talking about. You wanted to measure how acidic or basic, because as fish waste increases in the pond, the pH changes basically. So you are able to measure that and uh, do something according to your solution, of course. So this is a load cell. So this is used to measure weight. Okay, this is actually pulled out from one of the weighing scales. Okay, and yeah, I think that is it that I have. Yeah. So these are some common sensors. Okay, yeah, I think I have a few more. Yeah. So this is current sensor. So this measures direct current in form of a solar panel, DC battery, and things like that. And this is a sensor that is meant for alternating current. So this measures your AC mains. And yeah, another popular sensor is motion sensor. I don't have one of them handy, but there is another similar sensor called presence sensor. So there are various forms of motion sensor. So this one uses millimeter wave to measure presence of a human body. So this sensor, I actually have a home assistant, uh, setup at my home as part of my smart home. So this is a sensor I bought to detect people in the rooms. Okay, yeah. So these were some sensors, and I will just move on to a few actuators that I have. Okay, again, actuators are things that convert electrical signal into physical signal. Yeah, piezoelectric. Yeah, I actually have that. I missed to show. So this is a piezoelectric device. It basically uses vibration and force basically to form electricity. Okay, and then we have yeah, coming back to actuators, we have many different kinds of actuators. So this is called a relay. Okay, so there are different kinds of relay. So this is a mechanical relay and this is a solid state relay. And these are basically like your, you use a switch to switch on and off your lights, fans, AC, and all that. So these are when you want your smart home to switch on, switch off. These are the devices you use called relay. You want to display information, you have various kinds of display, LCD display and OLED displays. And you also have uh, a 7 segment display when you have very simple things like temperature or voltage. You want to show such things. Okay, and then there are motors, of course. They are the primary way to move stuff using electricity. Okay, so we have geared motors, which we typically use in robotics to move your wheels and stuff. And then you have a servo motor, which is used typically used in very. I hope you're able to see. Yeah, typically used in high torque environments, where at the tail ends of say aeroplanes and helicopters where you want to move control surfaces, they exert a lot of force, but they need very precise movement. And then another type of motor is called a stepper motor, typically used in when you want to move very precise amount of steps. They are called stepper motors for a reason. Okay, so I'm sure you have heard of 3D printing. So 3D printing is one place where stepper motors are used because you have to precisely move 1 or 2 millimeters to do things. Then there is a thing called solenoid valve. So this is basically the relay equivalent of a tap. So you use a tap to switch on and switch off water flow. So this is the electrical equivalent. So you supply this with electricity. This allows water to flow, water or gas to flow and not flow. And then you have your usual. Where did that go? You have speaker for audio based signals, simple speakers, and I think I missed the audio based sensor. So there is a microphone that you can use for audio based sensing. But yeah, then there is uh, then we have a water flow sensor. So this is used to measure the speed of flow of liquid. When you so things like places like fuel pumps, where you have to measure exactly 1 liter fuel. So places like that, you have such actuators. Okay, so yeah, so that covers sensors and actuators. So if you have any doubt in them, please put it forward there. I think we are close to the end of session. So just few more minutes. Okay, so we spoke about sensors and actuators. They are our sense organs and our muscles. And now time for the brain. The one that actually takes all that data and does either analytics or dashboarding or display, basically controlling and talking between all the sensors and actuators. So most popular microcontroller is a board called Arduino. So Arduino, Arduino. And so this is the most popular board in the Arduino series called the Arduino Uno, R3 specifically, revision 3. So recently revision 4 has come out. Then if you want more number of, okay, I think I will just quickly, I'll open one of the images. Okay, so yeah, so here I hope you're able to see. So I just wanted to give you a brief of what the controller actually does. Okay, so here you are able to see this row of this black set of rows. So these are basically pins where you connect wires. Okay, you connect your wire into, so let's say this distance sensor. So this distance sensor has 4 pins. Two of them are for power, two of them are for data. So those 4 pins connect to, so these rows of pins that you see here. So these are basically small holes where you can put wires with small pins, which are used to make electrical contact. So these 4 pins get connected to them, and this black color, the IC, integrated circuit, that we have here is what actually stores your program, which you can load through a USB port. Okay, so this is the common Arduino Uno board. Okay, so the most important parts that you have to know are the pins that you have to connect the wires, and your integrated circuit that actually does the program execution and all of that. Okay, so yeah, so that was Arduino Uno, and then we have Arduino Mega, which is basically more set of pins. So the previous one had 13 pins. This one has 54 pins to connect more devices. And then we have another popular set of boards called ESP based boards. Okay, so ESP8266 based boards are the older one, and then there is ESP32 based boards. So both of these are ESP8266 based boards. So these boards have Wi-Fi inbuilt. So you are able to directly connect them to your Wi-Fi to push data to the cloud service, or maybe have a mobile application. Okay, so we are going to come to mobile application and controlling uh, all the related things tomorrow. So as of now, we are only discussing the controllers. Okay, and then there is a smaller version of Arduino. This is called Arduino Pro Mini. So these also have the same set of pins, but it is so much smaller than the Arduino Uno. Okay, and then uh, so there are various other microcontrollers. Okay, so I have only Raspberries and Arduinos and ESPs currently, but the Raspberry Pi is a company that previously used to make computers. Now they recently started making microcontrollers. So this is Raspberry's microcontroller called Pi Pico, and then there are STM branded microcontrollers, PIC branded microcontrollers. Teensy is another popular board. So in all of these, Arduino has come out to be the standard most popular board. So typically all of these other boards can be programmed using tools that we use to do Arduino. So that is how, so it is like how we as a civilization have taken up English language because English was popular. Okay, all of us speak English now because English was popular. It is not our native. So similarly, ESP, Teensy, STM, Raspberry Pico, they have their own tools. But because Arduino is so popular, all of them are able to work with Arduino also, Arduino programming. Okay, then comes the computer side of boards, in case you have little more uh, computing power, if you need little more computing power, again in this space the most popular is going to be Raspberry Pi. So we have the original Raspberry Pi here. Okay, then we have the Pi 4 and the Pi 5. So these are all complete single board computers basically. So I can just show you. So you have your, give me a minute. Yeah. So you see these ports here. So these are USB Type C for power and HDMI ports for the monitor. And then you have USB port and Ethernet port for internet and keyboard, mouse, and all that. So that way, this entire thing is basically the same thing, the Raspberry that we had. Okay, so it is the same board. It is just in a case. So this board is a full computer. This runs Linux, and you can do all your use. In fact, one such board is actually controlling my TV outside in the living room. So I have put and I have loaded Android onto it and using it as a smart TV. So I can directly stream YouTube, Netflix, all that using this to my TV because my TV is old and it's kind of a dumb TV. Okay, and then there are other boards from NVIDIA. Okay, the graphics GPU manufacturer NVIDIA has. There are boards from Asus. There are boards from uh, Latte Panda. Okay, and then after Raspberry, there have been multiple uh, companies, because Raspberry is a fruit name. There have been other Banana Pi. There has been Orange Pi. Okay, so this is Raspberry Pi. It is like the original, and recently Raspberry has made up a even smaller version of the computer. Okay, so this is the Pi 5 in comparison to the Pi 0. So this is also a full computer. This is just the stick of gum size. Okay, you have your same, again in a case for you to see easy. So HDMI port, micro USB for power. You have the same set of pins that you can use to connect your sensors and stuff. So this runs a full operating system like Linux or Windows IoT Core, Windows on ARM. Okay, many Android, so many operating systems can run. So these are kind of the gateways in your IoT. So multiple devices like your ESP can have sensors connected to it, and they send data to a board like Raspberry, which actually do the analytics because they have much more horsepower in terms of computing. And this can run actually web pages, web servers. So I can just show you briefly. We have, so this is my Home Assistant's instance. So this is running on a Raspberry Pi. So a similar Raspberry Pi runs this particular Home Assistant's instance. So this is the operating system where all the various sensors are connected. Okay, so yeah, so that covers it about sensors, actuators, and controllers, use cases of IoT. If anyone have anything to ask regarding the sensors, actuators, anything we have discussed, please go ahead. Okay. Yeah. So I showed majority of what I have. So I have a small lab. I call it a lab maker space. I use it to do various projects, and I build products for different organizations and stuff. So primarily it was made for my madness. I wanted to do things, so I bought things. Okay. So anyone has to ask or tell anything? Okay. Otherwise, I think this is the end of the session. Okay, thank you for your time. So this is the first session. Next session, we will talk about, we are going to talk a bit about prototyping, soldering, and actually deploying your IoT products. Okay, programming, application development, and as I said, the open source home automation tool, Home Assistant, and then some bit of simulation. I'm going to show you a few projects to see how you can start learning, and then transition to maybe buying a kit and trying to do what you have simulated. Okay, so Raspberry Pi, Kunal. So Raspberry Pi there are various Raspberry Pis, okay, various models. So this is a Raspberry Pi 4. Okay, there is not so computing power. There is a lot of difference. So Raspberry Pi 5, the one with the silver thing, has almost 2 to 3 times power as the Raspberry Pi 4, even though it is the exact same size. Okay, so these are basically full computers. Okay, so I'm sitting on a computer with monitors connected, and I have presentation running, I have a browser running. So similar thing you can do on this, not as powerful as a full Intel or AMD based laptop or PC, because of course this is small. This is literally size of a credit card. Okay, so it is not as capable, but it is plenty capable for IoT use cases, web servers, and in fact, it can be used as it is meant as a tool for digital learning. Okay, whatever your application, whatever your scale, Raspberry Pi offers cost-effective, high performance for businesses and home. So that is their tagline. So their primary use, so the original Pi that I showed, they thought only a few thousand of these boards will get sold, but now they are at a point where millions of these get sold every year. Okay, so they thought only thousand of this will get sold, and now they sell millions of this a year. That is how popular it has got. Okay, because people previously you had to it was a lot of investment to buy a computer to actually learn programming, to learn application development, or as simple as you, I just want to watch YouTube videos to learn. I want to read blog articles, I want to read research papers. So those things were difficult. So, so a tool like Raspberry is able to help you with that. It is a full computer, and you can connect your keyboard, mouse to this. You run your operating system on it, and you are able to use it as a full desktop. Would love to know how you automated home converted. Yeah. So, automate how I automated my home is something that we are going to be covering tomorrow, part of the case study, as I told. And how I converted old TV to smart is not using a microcontroller, it is using a computer. Okay, microcomputer, single board computer it's called. Okay, the Raspberry. Okay, microcontroller is things like Arduino. They don't have enough power to run a full operating system. Okay, they are very low powered cores, only meant for running one program, simple program that you give it. That program can be as simple as keep reading the distance from the distance sensor. If the distance is below 5 centimeters, switch on this motor, say for opening the door. That is all. Simple program, 5 line, 6 line program. That is all your microcontroller can run. It can, of course, run complex program, but not as complex as operating system. Operating system is things like Windows, Ubuntu, okay, or in the popular circles we have Arch Linux and Kali operating system and all that. So those things can be run using Raspberry Pi and related, NVIDIA Jetson and the Latte Panda boards. Okay, yeah. So that is it. So that concludes the session. Thank you all for being here. Okay, I'll be here for another 5 10 minutes. You can ask me doubts if you have.
Okay, first of all, thank you, Abhinav, for this session. We are discussing for this session since very long. Finally, it's here.
Yeah.
And yeah, for everyone, I'm just asking please fill the form. Whoever are new, they can just join our group. We used to have like a very interesting project. We have a good collaboration with IIT Kanpur also. We are doing project there also. If you want to be a part of that, just join the group. And yeah, many interesting collaboration will happen soon in future. So yeah, please
Yeah.
be there.
Yeah. So if
And
you
yeah,
have,
if yeah,
yeah,
please.
please continue.
No, no, continue. It's okay.
No,
Done
in
from my
case
side.
anyone has any more doubts or you want to actually start learning, start making, again, as Akhilesh said, join the group, and we are there to share knowledge, help you people get up to speed. See, the purpose of this group and the purpose of the session is to teach you what is possible, how you can do it. It is not to handhold you. Handholding is possible, but there is that popular saying: "Give a man a fish and he eats for a day. Teach a man to fish and he eats for a lifetime." So that is quite apt here.
Yeah.
And thank you very much, Yantra and Akhilesh, for having me.
Thank you very much to you, actually. You
Well,
just give us your
welcome,
time.
welcome, and thank you all of you too for being here. So this is one of my largest audience online session. So I have trained close to 3,500 people, but majority of them have been offline. So online, this is the biggest crowd that I've been taking. But maybe next session, more of you will actually open up and share your anecdotes and oh, you just
And
unmute and
I
talk.
will, yeah, I will really appreciate like if anyone wants to make any project, we will like have a collaboration kind of thing, and we'll make something on that page. So
Yeah,
like yeah, Abhinav will also help, I guess. So he
yeah,
is there in the group, and many more people are there. If you want any help, they are there to help you out.
yeah. Good. So thank you, everybody.
Yeah, thank you for your time, guys. I'll just record. Let's stop the recording.